So this was the question from June 18, variant 42. Okay, a man has mass 80 kg. He runs along a horizontal road against a constant resistance force of magnitude P. The total work done by the man in increasing his speed from 4 to 5.5 while running a distance of 60 meter is this. So guys, it's clearly a question on work energy situation here. So here is the speed 4, here is the speed 5.5, the distance 60 meters, and this is the backward force over here. So we're going to use this golden rule over here: work done by the driving force minus work done by the resisting force equal to change in kinetic energy plus change in potential energy. This work done by the driving force has been given to us, that is the work done by the man, and then the backward force is P times the distance. We use the formula here, the work is F into S. So F over here is P and the distance covered is 60. And this is to change in kinetic energy half. The formula is half M into V square minus U square. So you must have calculated this. So what is this P? Okay, this is 10.5 newtons. We can check our answer as well. Yeah, this is 10.5. Okay, so let's move to the question number 2 then. Okay, question number 2, I need to clear all this. Okay, and you people give it a try first. Okay, a train of mass 240,000 kg travels up a slope inclined at an angle of 4 degrees. So let me draw that. This is going to be something like this. Okay, so here is that 4 degrees. This is 4 degrees over here. Okay, so here is, let's show the train like this over here. Okay, and here is its weight downwards. That is going to be 242,400,000 newtons, है ना? Yeah, this is 2.4 millions in fact. Okay, so I need the component of this weight in parallel to this inclined surface here. So we're given that the angle is 4 here. Okay, so this component is going to be 2.4 into 10 raised to power 1, 2, 3, 4, 5, 6. Okay, times sine 0.4. That is the component of the weight parallel to this inclined surface over here. Okay, so rather than writing all these zeros, I have choose the standard form here. Okay, we don't need this R right now. Okay, it says there is a constant resistance of magnitude. So this is 18,000 Newton force backwards. Okay. Next it says,
sorry, Intzar.
yeah.
Sir, sin 4 नहीं होगा, आपने sin 0.4 लिखा हुआ है.
Oh yes, it is. Why did I write sine 0.4? Oh, because previously we had 0.05. Okay, thank you, but sine 4. Okay, it says at the instant when the speed of the train is 15. Now suppose here is that instant when the speed is 15 meter per second, its deceleration is 0.2. So up the slope, its acceleration is minus 0.2 meter per second square. Find the power of the engine of the train. So again, you know that power formula, Maria, that is power is equal to F into V. Okay, so you need to have that driving force with you. Okay, so you already have the speed over here, which is 15. If you find that driving force, you multiply that by V, you will get that. Yeah, you have to find that power. Okay, so let's do that. So the forward force we have to find. Let me say this is F. Okay, we have two backward forces. One is 18,000 and the other is this 2.4 million times sine 4. Okay, this is 2,400,000 times sine 4, and that is equal to I have to write it down here. MA, the mass of this is 240,000 and acceleration is minus zero point 0.2. Please solve all this and tell me what is that F over here. This F, the forward force. Yes. Now, while you're telling me the value of this force, do not delete it from the calculator. This is 137. Okay, newtons. So we are interested in power. So you multiply this F, which is 137,415 times that 15. So now tell me, this is the answer that we need. 206,122.5 joules. Okay, this is 1, 2, 3, 4, 5, 6. Okay, so this is 2.06 into 10 raised to power 6 joules. Sorry, watts. I'm putting the wrong unit here. This has to be watts. Okay. So guys, this third question is clearly on resolving forces. It says the three coplanar forces shown in the diagram have these magnitudes. Given that the three forces are in equilibrium, so you have to pick this word here. So we have to find the value of theta and P. We had the same question in the June 19th question paper as well. Okay, so we need to resolve these forces here. So this would be resolved like this. This is your 2 cos theta. I hope you remember how to resolve this. And this is 2 sine theta over here. Okay. And then I resolve this force here. So this one is 3 cos 60 and this one is 3 sine 60. Okay, so when we given that the three forces are at equilibrium, so that means the resultant of the three forces is 0. This also implies that Rx will be 0 and then Ry will also be equal to 0. Okay, so this is the Ry over here. Okay. So Rx is now going to be 2 cos theta minus 3 cos 60. And I put that directly equal to 0. Okay. So we can find this theta from here. 2 cos theta, that is going to be equal to 3 cos 60 is 3 by 2. So this is 1.5 here. So your cos theta is 1.5 over 2. And please tell me what is tan. 41.4 degrees. Okay. And then from the vertical parts, we have this 2 sine theta plus there is another upward force 3 sine 60 and minus this P that is equal to 0. This is the Ry, okay? And then you see that this P is going to be 2 sine theta plus 3 sine 60. You use this value of theta here and tell me what is this P? Okay, this is 3.92. So we have the answers with us as well. So let's see what is the answer to this question. This is, I think, the third question here. Yeah. So yeah, these are the answers here. Okay, so we are going to move on to the next question then. So this fourth question, you give it a try first and then I'll be following you guys. Okay, a particle P moves in a straight line A, B, C, D with constant acceleration. So please, you have to underline this. When you have constant acceleration, so that is your kinematics 1. You can use the Newton's equations of motion here, known as VAT. Okay. Okay, so it says, let me draw this. So this is your A, let's say here it is B, here it is C. It says the distance AB is 100 meters. Okay, this distance is 100 meters. The particle takes 4 seconds. This distance is 148 meters, by the way. And it says then it takes 4 seconds to travel from A to B. So the time here is 4 seconds. And 4 seconds to travel from B to C. The time is same here as well. Okay, and show that the acceleration of p is 3 meter per second square and find the speed of p at a. So one thing is that we have to find this u, the initial speed, what is that speed here, and we have to find the acceleration as well. Okay. In fact, we're to show that the acceleration is 3 meter per second square. Now, there is a problem here. Some students start using this acceleration as 3. So you can't do that, okay? You have to prove that this acceleration is 3 over here. Mhm. Just 1 minute. Let me pause this. Now, I suspect that since we have to find two unknowns, one is the initial speed at a and then the acceleration. So we might have two equations in u and a, and we'll have to solve them simultaneously. Okay. So if we consider this AB segment, okay. So can I say for the AB segment, we can use that equation S equal to UT plus half AT square. So this is going to be 100, that is equal to 4U plus T square is going to be 16. So this is 8A. We can write this as, okay, let me write this as 25 equals u plus 2a. And I can say u is going to be 25 minus 2a. That is my first equation. And then I'll be considering, I'm just like trying this. Let's consider the segment AC now, okay, from A to C. Uh, Again, we can use S equal to UT plus half AT square here, okay. So now the distance is 248. Yes, the distance is 248. We have to find the initial speed. The total time taken is 8 seconds. So this is 8u and half of 64 is 32. This is 32a. I think I can take 8 common from here. So this is going to be 31 equal to u plus 4a. And your u is going to be 31 minus 4a. That is your second equation. So guys, you solve these two equations simultaneously and you have to tell me that what are the values of u and a. So what is your u and what is your a? U is 19 meter per second and A should be 3 meter per second square. So that is how you solve this question. Okay. Let's see what's there in the second part. Yes, yes, yes. I'm stopping here. You can see this. So let's move to the second part then. So here's the second part. It says P reaches D with speed of 61 meter per second. So I'm just going to add that information here. Like if we have the point D over here, so it is reaching here with the speed 61 meter per second. Okay. And now we have to find the distance CD, that how much is this distance over here. Give it a try, please. So when we have to find the distance CD, so I'm just going to take information from here that I am clear that my acceleration for this part, CD, is going to be 3 meter per second square. I think we can find the speed at C. Hannah? Yeah, that will help us to determine this distance. Yeah, 2as equal to v square minus, okay, that's so there are two ways. One is that you can consider the whole part from a to d using that equation, 2as equal to v square minus u square. So let's do this then. Okay, so I need to erase this before I do that. So we have the speed. Now we have the initial speed there, which is going to be 19. I'm just going to keep it and erase the rest of this. Okay. So we have now the speed here at which is going to be 19. So this speed over here is 19 meter per second. So let's find the total distance AD, that is going to be found through 2as, that is equal to v square minus u square. So this is 2 into 3 into s, that is equal to 61 square minus 19 square. So guys, what is the total distance? 560? Okay, so they are saying this is 560 meters. So the distance CD is going to be this 560 minus AB plus BC, that is 248. So what is this? 312 meters. Okay, next question then. Here is the fifth question. Guys, you give it a try first, and then we'll try it. Okay, question number 5. It says a particle of mass 20 kgs on a rough plane inclined at an angle of 60 degrees to the horizontal. Okay, so 60 degrees to the horizontal, it is going to be like this. So we have this angle here, 60 degrees. And here is that particle, which has a mass of 20 kg. So this means I have to show its weight down here, which is going to be 200 newtons. And I need to resolve this, okay? Because you see, it says there is the coefficient of friction is required. So something to be done with the R as well, okay? So this is going to be 60 here. So this is 200 sine 60, and this one is 200 cos 60. It says equilibrium is maintained by a force of magnitude p newtons acting on the particle in a direction parallel to a line of greatest slope of the plane. Now please see one thing over here. We are not told that this force p is acting upward or downward, okay? And is asking you, he says the greatest possible value of p is twice the least possible value of p. So we need to have two diagrams here, guys, because we shall assume in one diagram that p is acting upwards, and in the second diagram we'll assume that p is acting downwards, okay? So this is again that object shown here. This is its weight, which is 200 newtons, okay? And I will be resolving this weight parallel and perpendicular to this surface, okay? So we have this as 200 sine 60. This one is 200 cos 60, okay? Now, if I have this force up here, this is the force P, okay? Then I'm going to assume that the frictional force is acting downwards here. The X is my frictional force, okay? And in the second situation, I am going to assume that this force P is acting downwards, okay? And the frictional force is acting upwards over here, okay? And this is my R over here. Okay? Acha. Now, in both of these diagrams, you must be able to determine the value of R. So R is clearly 200 cos 60. R is going to be 200 cos 60. And if you keep this coefficient of friction as mu, then your X is going to be mu R, okay? So this is going to give you 100 mu. That is the frictional force over here. Ajay guys, in which case do you think that this force P is greater when it is acting upwards or when it is acting downwards? Upwards, okay? So the greatest possible value of P is twice the least possible value of P. Now, in this case over here, your P is going to be X plus this 200 sine 60. That is going to be because they are at equilibrium. Look at this equilibrium over here, okay? So this P is going to be X plus 200 sine 60. X is 100 mu and 200 sine 60 is, I think, 100 under root 3. Hai. That is the value of 200 sine 60. And in this case, let me call this P1, which is the maximum P here, okay? This is P1 and this is P2. So in this case, your P2 plus this 100 under root 3, that is equal to 100 mu. So this P2 is going to be 100 mu minus 100 under root 3. Now, using this condition here, that the greatest P is twice the least P. So can I say now that this 100 mu plus 100 under root 3, that is twice this 100 mu minus 100 under root 3. So try to keep the figures in exact form as long as you can, okay? So this is 100 mu plus 100 under root 3, that is 200 mu minus 200 under root 3. So we have 100 mu, that is equal to 300 under root 3. So your mu is going to be under root 3. That is the mu, okay? He was saying find the value of the coefficient of friction between the particle and the plane. You must have some question, some problem here. जी बेटा, आप कुछ पूछ रहे हो? नहीं? क्या आप लोगों ने इतना शोर डाला हुआ था, हाय मैकेनिक्स, हाय मर गए यार? ये आप लोग अगर इस डायग्राम से कंफर्टेबल है, इसका मतलब है आप तो चैंपियन है मैकेनिक्स के। अगर आपको नहीं लग रहा कि हाय यार की बनाया है सर ने यार थे, ठीक है ना? अगर आपको ऐसा नहीं लग रहा, इसका मतलब है आप तो चीते हैं यार मैकेनिक्स से फिर, ठीक है ना? किसी को लग रहा कि यार ये पता नहीं क्या यार, ये पता नहीं, बस चले फिर आगे, ओके। और ये आप लोग कोई बुक से क्वेश्चन नहीं कर रहे, पास पेपर से क्वेश्चंस कर रहे हैं, तो अपने आप को अंडर एस्टिमेट ना क्या करें। चलें देखें क्वेश्चन नंबर 6। So you try this question number 6, okay? Okay, this looks to me a question, rather simple question on kinematics 2, where we have calculus to be applied here. So we're given the expression for the acceleration, which is 6 minus 0.24 t. Now remember, if you differentiate the displacement, you get the velocity. And if you differentiate the velocity, you get the acceleration. And if you integrate the acceleration, you get the velocity. And if you integrate the velocity, you get the displacement back, okay? So he says the particle comes to instantaneous rest when the time is 20. So indirectly is giving you when the time is 20, the velocity is 0. So that you can find that C when you will be integrating it, okay? So this velocity is going to be the integral of 6 minus 0.24 t dt. So we have the velocity 6t minus 0.12 t square, because t's integral is t square over 2, and you simplify this with 0.24, and never forget to write that plus c. If you don't write this plus c, the whole solution would be ruined, okay? So remember, whenever you integrate, there are no limits to be applied. Do write that plus c, okay? So we'll be using these values over here. B is 0 and t is 20. So let's say, what do we get? Someone please do that calculation thing for me and tell me that what is this c? Minus 72. Believing this to be correct, now the velocity has become, let me cover this here. We don't need this. Okay, so this velocity is now 6t minus 0.12 t square and minus 72. It says find the value of t for at which the particle is again at instantaneous rest. So you need to put this velocity equal to 0, okay? So you put that equal to 0 here so that you can solve this equation. So you can use quadratic formula or whatever you want to do that. So 0.12 t square minus 6t plus 72 equal to 0. You must show that step required to solve this, and then you can use your calculator, okay? 6 plus minus, and there is this 36, and you have minus 4 into 0.12 into the 72 over this 2 into, and now you use the calculator and tell me what are the two values. One will be 20 and the other is 30. Okay, so you see that is the second time when it is again at instantaneously rest. Okay, let's see what is there in the second part of this question. It says find the distance the particle travels between the times of instantaneous rest. Okay, I would strongly suggest you guys draw a rough sketch, okay, for this. Now, if you look at this equation, guys, the equation of this velocity over here, the original equation over here, this one, velocity equal to this. Now, would that be an upward curve or a downward quadratic curve? A happy face or a sad face? Sad face, okay? So this would be a sad face. Let me erase this before I do that, okay? So, okay, so this would be a sad face, okay, like this. And we already know that this is going to be at these the times 20 and 30 when this is instantaneously at rest, okay? And when the time is 0, the velocity is minus 72. So this is going to be something like this, minus 72. So this is the velocity time graph. Okay, so once you have this sketched, guys, this really becomes so easy for you to answer this question. It says between the times when it is instantaneously at rest. So Khuzaima, you have to find this area over here. Okay, so you simply say, okay, this x is going to be limit from 20 to 30, and this is going to be, write this actual form, not with the one where I took that minus common. So 6t minus 0.12 t square minus 72. This time this is a definite integral. You only have to integrate it, and you see this will become, I'm going to do this step and then you will be giving me the answer, okay? 6t's integral is 3t square, okay? Minus 0.12 t square is going to be minus 0.04 t cube. And this one is minus 72t. You can do that in steps. I'm just skipping some steps over here, okay? Now, please, guys, put the limits here and tell me how much is this distance. So these clever students have already calculated it. This is going to be 20 meters. So please, you have to show that step here where you are putting those limits into it. Okay, so this was the second part. Let me take its picture. Okay, now we move on to maybe the last question of this paper. Okay, and we'll do that in the next segment. Okay, the last question of this paper. As shown in the diagram, a particle A of mass 1.6 kg. I am really fond of showing the weight, okay, whenever this is about connected particles. So this is 16 newtons here, lies on a horizontal plane, and a particle B of mass 2.4 kg. So I would be showing this weight as well. This is the weight here, that is 24 newtons, okay? And I should immediately be resolving this weight here, okay? So now this is going to be 24 sine 30, and this one is 24 cos 30. Remember, this angle is always same as this given angle over here. So that is why this angle is going to be 30 here. Okay. Uh, okay. So now, next it says the particles are connected by a light inextensible string which passes over a small smooth pulley P fixed at the top of the inclined plane. The distance AP is 2.5. The distance of B from the bottom of the inclined plane is 1 meters. So this distance is 1 meters over here. There is a barrier at the bottom of the inclined plane preventing any further motion of B. Like if B reaches at this point, so this will not be going further, okay? The part BP of the string is parallel to a line of greatest slope of the inclined plane. Okay, so this BP is that is parallel to this inclined plane. The particles are released from rest. So the initial speed is 0 here. With both parts of the string taut. Given that both planes are smooth, oh, this is the very important information here. So that means there is no frictional force, okay? Find the acceleration of A and the tension in the string. So we have to find the acceleration here. So let me cover this because I don't need this information now. I have to do my working here, okay? So, so we have to find the tension and the acceleration. So it's a typical question, guys, here. You will have to, you always show the tension directed towards the pulleys, okay? So here is the tension over here, okay? Now, you will have two equations, one from the particle A and other from the particle B, from that lovely formula which is F equal to ma. That is the lifeline of this whole mechanics, okay? So if you look at this particle A, when you release the system, B would be going downwards. So A would start sliding towards the pulley, okay? So what is the net horizontal force on this particle A? That is T, okay? There is no backward force right now, okay? So we can say from A that this T is simply equal to MA, that is 1.6 A. Then we look at this particle B, guys. Particle B, let me call this equation number 1. Now the particle B is sliding down the plane. And how many forces parallel to this plane are acting on it? Two forces. One is its weight, which is 24 sine 30. We know sine 30 is half. So that is going to be 12 and minus the upward tension. And that is equal to 2.4 A. That is your second equation. So if you solve these two equations simultaneously, you will be able to find the acceleration and the tension. Okay, so please do that for me quickly. Tell me how much is the tension? Okay, yeah, tension is 4 point. Okay, and A is 3 meter per second square. Okay, So from this, I'll be moving towards the second part and I'll be using the same diagram. So let me just slide down here and see what is he asking in the second part. He says it is instead given that the horizontal plane is rough. Okay, so please remember that the horizontal plane is rough and the coefficient of friction is given. Okay, let me write it here. The coefficient of friction is given, that is 0.2. Okay, the inclined plane is smooth. Find the total distance traveled by A. Okay, so let's slide up and we are going to use the same diagram. I'm not going to draw that again. Okay, so here is that diagram. I'll be clearing some areas from here. So we don't need all this. Okay, so I will be covering all of this so that I can do the working here. Okay, so here we are, guys. Acha, now this is a typical question whenever you have the connected particles. He says, what is the total distance covered by this A? So please be very clear over here that when this B would hit the barrier, B would stop. Will A be stopping immediately with the B? No, it will be sliding a bit towards the pulley because of its momentum. Okay, so you can, in such case, this is really a useful tip that you divide the motion of A in two parts. One, when the string is taut, okay? When the string is taut, okay? And secondly, when the string is slack, okay? When the string is taut, the tension would be in action over here, okay? And when the string is slack, so you'll see that what forces are acting on it at that moment, okay? So, okay. So now, guys, we have the friction thing over here now coming up because this horizontal surface is not smooth. So this R is going to be in action now, okay? So I have to show R over here so that I can determine that what is this backward force over here, okay? So guys, this R is, what is this R now? R is 16 and you have been given mu, that is 0.2. So we can find this X as mu R, okay? So this X is going to be 3.2 newtons. Okay, so now let's find the new acceleration now. Okay, so we have from A, you have the equation that this T minus X, that is going to be 1.6 A. We have to recalculate the tension. The situation has changed. You cannot use the tension found in the first part. Okay, so this is T minus 3.2, that is equal to 1.6 A. That is your first equation. And from here, this is the smooth area over here. So this would be the same as 24 sine 30, that is 12, minus T, that is equal to 2.4A. That is your second equation. I'm not interested in finding this tension. So just tell me how much is the acceleration here. 2.2. So after solving them simultaneously, you get the acceleration 2.2. So now let's find the distance covered when the string is taut. How much distance will it cover when the string is taut? 1 meters. Okay, so there's no need to calculate that. But why did we calculate this acceleration? I'll tell you, just wait. Yeah, okay. Now let's say it reaches here, okay, and B hits this ramp. This string will be no more taut. This will go slack. And now this particle A will be moving freely. And what force would be acting on it? Friction. Okay. And will that still be accelerating or decelerating? It will start decelerating. Okay. So now let's find, now since I have to find that how far it goes, suppose it goes up to this part over here. What will happen when it reaches the maximum distance covered? V would be 0. Okay, V would be 0 meter per second. What would be the initial speed here? we can calculate using this acceleration. Okay, let's find this u, which is actually the v for the first part. Okay, so we have the initial speed 0, we have the acceleration 2.2. Okay, um, we have the distance, which is 1, and we need to find this v. So what equation you will be using? So 2as is v square minus u square. So this is 2 into 2.2 into 1, that is v square minus 0 square. So this is v square, that is 4.4. And your v is going to be, don't find this, let it be the square root of 4.4. Okay, don't find this through the calculator. Okay, now when it is going to move with the string slack, we need to know, okay, we have got this under root 4.4 over here. Okay, we have the final speed 0. We need to calculate the distance over here. Okay, so you see that using that favorite f equal to ma, we can determine its acceleration. Okay, now will this frictional force change? No, this will, because the surface is same, the object is same. So we have no forward force. There is a backward force, which is 3.2, and the mass is 1.6, and this is a f equal to ma. So your acceleration is going to be minus 2 meter per second square. So we have the acceleration here, which is minus 2 meter per second square. Using all this information, let's find how much distance has been covered. So we'll be using that 2as equal to v square minus u square again. So 2 into a, which is minus 2, distance has to be calculated. V is going to be 0, okay? And the initial speed is under root 4.4, its square is going to be 4.4. So this s is going to be 1.1. And what is the total distance covered by this a? 2.2. Never forget to sum this up at the end. So the total distance covered is 1 plus 1.1, that is 2.2 meters. You better highlight it. Okay, and this ends our paper here. If you have any question, please let me know. Why do I always make silly mistakes? This is 2.1. Okay, this is 2.1. Okay, guys, thank you for being with us. Let's see with you guys in the next paper. That would be the P3, inshallah.